quadratic equation, x raised by 4. Quintic equation, x raised by 5, so on and so forth. So without an equal sign, like a 4x minus 3, we call linear expression. If we have an equal sign up here, it's called a linear equation. If we put f of x equals to 4x minus 3, we call linear function. All right. So you see 3 different kinds of areas talking about linear expression, linear equation, and linear function. And some important terms, degree of a polynomial, right? So linear is degree 1, constant is degree 0, and that's also leading term and leading coefficient. Let's see this one. We have this quadratic polynomial function, right? Quadratic function or polynomial degree 2. Well, leading term is 9x squared. Because it's a square, so it's a degree 2. A leading term is 9x squared. A leading coefficient is a number before x squared is 9. All right, so we have these 3 terms. We have 9x squared, 6x, we have 1. 1 is constant, right? But 6 is a coefficient of x, 9 is a coefficient of x squared. 9 and 6 are not constant because they are scalars. You know, their value depends on x squared. This one depends on x. I think everyone knows how to solve linear equations, right? Linear equations, like, let's see, we have this one, right? This is called a linear equation. We have 4x minus 3 equals 0. We solve by doing, 4x equals to 3. We add a 3 on both sides. Then we divide by 4 on both sides. So we get x equals to 3/4. Right? So everyone knows how to solve this. What does it mean to be a solution of a linear equation? Well, let's see this one. This one we have y equals to 2x plus 4. So this is a linear equation with 2 variables. Linear equation with 2 variables. Usually we need another linear equation to solve. Okay, so if it's only one, it represents a line, right? The graph of this is a straight line with a slope of 2, right? With a y-intercept 0, 4. But with one of these equations, we can ask, is 2, 2 in the solution set? Well, let's see it. So 2 times 2 plus 4 equals 8. But a y equals 2, so it's not. Right? 2, 2 is not a solution. Because 2 not equal to 8. Is 0, 4 a solution? Y equals 4, so 2 times 0 will be 0, 0 plus 4 equals 4. So yes, 0, 4 is a solution. There are infinite many solutions for this linear equation with 2 variables, right? Because it's a line goes on forever. So it has infinite many solutions for this. If we want to solve for one solution or special solutions, we need 2 to make a system. A polynomial equation is an equation that contains a polynomial expression. The degree of the polynomial equation is the degree of the polynomial. Let's say quadratic equation. We have ax squared plus bx plus c equals 0. Well, a, b, c are some numbers, and a is not 0. B can be 0, c can be 0, but not a. If a is 0, we have linear expression. It won't be quadratic anymore. And then we call quadratic equation degree 2 polynomial because it's x squared. This is a degree 2 polynomial. Let's see this one. U times u plus 1 equals 2. Right? That's u squared plus u minus u equals 0. So we have this all examples of the degree 2 polynomial equations. Right? This one same thing. 2x minus x squared equals 0. X squared plus 3x plus 2 equals 0. X squared minus x minus 6 equals 0, right? All those are quadratic equations. Before we solve quadratic equations, something called a zero property, we always use it. So zero product property. If we have one expression multiplied by another expression equals 0, so this star icon representing multiplication. That means A can be 0, B can be 0, or both of them are 0. All right, so we use this to solve quadratic equations. Let's see, we have this. We have factor x minus 2, we have factor x plus 1. If those two multiply equals 0, that means each one can be 0. That means x minus 2 can be 0, x plus 1 can be 0. Solve that, we get x equals 2 and a comma negative 1. So this is called a zero property. Right? So that's why when we solve quadratic equations, we always want the right-hand side to be 0. We always move every term to the left-hand side and leave the right-hand side to be 0 because we could use the zero property. Right? In this case, this is a factor, this is a factor, multiply equals 0. So we see each factor can be 0, right? So x minus 3 is 0. Why I read A here? So that means x minus 3 can be 0, x plus 2 can be 0, right? Then solve this, x equals 3 comma negative 2. Indeed, 3 minus 3 will be 0. 0 times anything will be 0. Negative 2 plus 2 is 0. 0 times anything will be 0. Right? The equation holds. Well, let's see this one. We have 2x plus 1 times x equals 0. Two factors, right? One factor is 2x plus 1, binomial. One factor is x, monomial. So by zero property, each factor can be 0. So we solve the first one, x equals negative half. The second one, x equals 0. Difference of two squares. 3 squared minus m squared, right? That's 3 minus m times 3 plus m. Each factor can be 0. So we solve, we get m equals 3 and negative 3. X minus 7 minus 10 times x divided by 7 plus 10. Again, difference of two squares equals 0. Means each factor can be 0. Right? We solve this. So that means the first one, hold on a second, I should put it. Right? That means each factor is 0. If this one is 0, we move negative 10 to the other side. We have x over 7 equals 10. We multiply by 7 on both sides. So x equals 70. This one move 10 to the other side becomes a negative 10. We multiply by 7 on both sides. We get negative 70. So x equals 70, negative 70. This one is a perfect square. Perfect square means we have two of the same factor, x minus 6 times itself. We'll just have to do once, because two factors are the same. So that means x minus 6 is 0, which means x equals 6. Only one solution. We see difference of two squares, we get two solutions. Yeah. Normally, we get two solutions for quadratic. So quadratic has at the most two solutions. You can have no solution, or maybe one solution, or two solutions, or at the most two solutions. So this is the case to have one solution. Sometimes we may not have solution. We will see that later. So let's see this one. Yeah. You know, quadratic equation, if we can put in a factor form, we would like to do that. Once we put it in factor form, we use zero property. If we cannot factor them, we can plug in quadratic formula, right? Negative b plus minus square root of b squared minus 4ac divided by 2a. We can always do that. We can always apply the quadratic formula. Well, this one can be factored. This one can be factored. So 3/9 squared can be thought as parentheses 3x squared. Right, let me write this process. I remember last class we talked a little bit about this. So think about 9x squared. That can be written as parentheses 3x outside squared, right? Then 1, of course, 6x. 6x is 2 times 3x. Right? Then 1 squared is just 1. Right? So we can come up with this. We see, okay, remember m plus n, right? M squared, m times n. We could think about this. So I should put this one up front, maybe. So usually we consider the first one, first term and last term. Okay. So you see, first term squared, 1 squared. So this we do backwards. When we do factoring, we do backwards, right? We think, okay, 9x squared is 3x squared within parentheses. 1 is 1 squared. Right? 1 is 1 squared. I should put 1 squared here. 1 equals 1 squared. Then we check the middle term. The middle term, 6x, can be written as 2 times 3x times 1. Bingo. That's 3x plus 1 squared. Right? First term is 3x. Second term is 1. And the middle term, we check 3x times 1 is 3x. Double it. Indeed, 6x. Right? So square equals 0, that means we square root both sides. 0 square root is still 0. So 3x equals negative 1. Then x equals negative 1/3. But this is a minus 6x. Right? Minus 6x, we think about negative 1 squared. 9x squared is still the same. Maybe let me just copy this. So this is thought process. Once you get good at it, you don't really need this. So 9x squared can be written as parentheses 3x squared. And because the main term is negative, so the factor has to be negative. So 1. 1 equals to negative 1 squared. All right. Then negative 6x, where does this come from? It comes from 2 times 3x times negative 1. So that means we have these two factors. We have 3x minus 1 squared. Right, 3x minus 1 squared. Then that means it's 3x minus 1 equals 0. Then we solve, we get x equals positive 1/3. Anyone has any questions?
Professor, how come
Yeah.
how come you put that 1 equals 1 squared?
Because remember when we see perfect squares last class,
Huh.
we have perfect squares has this a plus b squared a square a plus b square equals, oops, equals to first one square square the first one, square the second one, then the middle term comes multiply the first one and the second one, then double it. It's a formula of perfect square.
Oh, okay, thank you.
So here we're doing backwards. We figure out, okay, this one is 3x squared, and 1 is 1 squared. And then we check the middle terms. Middle term has to be checked. Middle term comes from multiply those two, a and b, then double it. Indeed, that's 6x. Any other questions? Okay. Maybe I'll leave you some to practice later. So let's see this one. 4x squared plus 20x plus 25 equals 0. Well, again, we do the same thing. We do the same thing. We think, okay, 4x squared can be written as 2 parentheses x squared. Okay. Then 25 equals to 5 squared. Right? So we're thinking, okay, that has to be, looks like 2x plus 5 squared. But then we have to check the middle term. We check the middle term. The middle term is 20x. Always difficult to do this. Okay. The middle term is 20x. And 20x has to be 2 times 2x times 5. And indeed, 2 times 2x, 4x, 4x times 5, 20x. Bingo. So we can write it as 2x plus 5 squared equals 0. Then we solve 2x plus 5 equals 0, x equals negative 5 over 2. Or the next one is minus. Minus, we just have to change 25 to be negative 5 squared. Right, 25, because the middle term is negative, and the last term is positive, that means we have negative 5 squared. So we write as 2x minus 5 squared. Then x equals a positive 5 over 2. Any questions? Okay, let's see this one. This one looks a little bit different. Right? First step, we want to put everything on the right-hand side. We leave the right-hand side to be 0. First step. Then we see if there's a common factor in those 3 terms, trinomial, right? Yes, indeed. We see everyone has a 2x as a common factor. So we factor out 2x. Then ax cubed becomes 4x squared inside. 40x squared becomes 20x inside. 50x divided by 2x, that's 25. Now this one we already factored. That's 2x plus 5 squared. So we write as 2x times 2x plus 5 squared. Now we have 3 factors, but those 2 factors are the same. So we just do this. 2x equals 0, right? 0 property. 2x plus 5 equals 0. So solve this, we get x equals 0 and negative 5 over 2. Any question? Okay, keep going. Next one, we see difference of 2 squares. Okay. So again, we do the same thing. Right? But this time, maybe we'll move 9 to the other side because it's the equation. Right? It doesn't really matter. And we move 9 to the other side becomes negative. So we have 4x squared minus 9 equals 0. Or we can write as 4x squared minus 9 equals 0 because it's an equal sign. If it's inequality, we cannot switch the sides. But because of the equal sign, we can switch the sides. And the 4x squared we think as 2x squared, right? So thought process. Right. The 9 is a 3 squared, right? 9 is a 3 squared. So we write, let me write 3 squared this way. Difference of 2 squares. So that's a squared minus b squared equals a plus b times a minus b. So we write that as 2x plus 3 and 2x minus 3. Right? That's how we factor difference of 2 squares. Then by 0 property, the 2 factors equal 0. So we solve, we get x equals negative 3 halves or positive 3 halves. Any questions? Okay, let's see this one. X squared over 16 minus 25 equals 0. Again, we think x squared over 16, that's x over 4 squared. That can be written with parentheses, right? So this is a crucial step. X squared over 16 is x over 4 squared. Then 25 is 5 squared. So we see a squared minus b squared form. So then we have x over 4 minus 5, x over 4 plus 5. Then by 0 property, each factor is 0. Then we move 5 or negative 5 to the other side. Then we multiply by 4 on both sides. So x equals 20 and negative 20. Any question? All right, keep going. Okay, a concept is called zeros of a function. Right? So for any function, when we set f of x equals 0, so when the function value is 0, f of x equals to 0, you see not x, right? X can be any number. F of x is 0, basically means y value is 0. Then x is called a zero of the function because x value will cause the function to be 0. So we call x is called a zero of the function. And we know it because before we call x-intercepted, remember? Right? Y value is 0, x value. So we call it x-intercepted before. But under the context of functions, we call x is a zero of the function. axis. So if x is 0 of the function, it's the x-intercept. Let's try to sketch some intercepts. Okay, let's see this one. Find the 0 of such function. Well, this by definition, that means the function is 0. So that means x squared minus 2x plus 1 equals 0, right? Well, that's easy. That's x minus 1 squared, right? So that's x minus 1 equals 0, which is x equals 0. So f of 1 is 0. So 1 comma 0 is x-intercept, and the 1 is the 0. 1 is the 0 of this function. Sounds weird, huh? Well, y-intercept is simpler, right? Y-intercept means plug x value to be 0. So x is 0. So y-intercept is f of 0. Plug in, so we get a 1. So 0 comma 1 is a y-intercept. Right? Let's see these examples. So this f of x is defined as a factor of two binomials. Right? So this function, quadratic function, in its factored form. Quadratic function, we have three forms, right? We have vertex form, we have standard form, we have this factored form. Find its zeros. Well, find its zeros just set to be 0. Set the function to be 0. Then factor out. Factor out, solve, so x equals positive 2 and negative 3. So function has two zeros, right? 2 and negative 3. Which means we have two x-intercepts, 2 comma 0, negative 3 comma 0. Any question? All right, let's try to see this one. Again, find the zeros of this function. So we set the function to be 0. We factor it. So this can be factored. So how do we factor this? Let me write down the thought process. Let me use green color. Right. So we think ax squared, so the first term can be thought as maybe 2x times 4x. Right? Then the last term, negative 3, can be thought as, because we also, remember m and n, right? We also want to do the two things. So the factors of negative 3 to play with the factors of ax squared to get the negative 2x for the middle term. So we think, okay, we need a 1 and a 3, but which one is negative? Because we have negative 3. And which one we want to multiply? So we have two factors of ax squared. We have two factors of this. And how should we justify the sign? And how do we play with these two factors? Well, we think if we do 2, I'm going to use blue color, times 3, we get a 6, right? And if we do 4, multiplied by 1, we get a 4. So the distance between 4 and 6 is 2. But now the midterm is negative, so we need negative 6. So we're going to put this one as a negative 3 and this one as a positive 1. In this case, so we want to do 2x multiplied by negative 3. So we better put them in different parentheses. So that's why we put 2x plus 1. Because those two won't get multiplied with each other, right? We want 2x multiplied by negative 3. So let me change this to be blue color. So we want those two to multiply. What did I do with this one? I want these two to multiply, so we can get negative 6x. And we want 1 and 4x to multiply to get a positive 4x. Then negative 6x plus 4x give us negative 2x. Right? Should I write down? Maybe I should write here. So negative 2x comes from 2x times negative 3 plus 1 times 4x. Or 4x times positive 1. Okay, let me change those two. So negative 2x comes from 2x blue color, negative 3 blue color, and 4x pinkish color, positive 1 pinkish color. Okay. When we add those two, indeed, we get negative 2x. So bingo, we just go ahead and write down 2x plus 1 times 4x minus 3 equals 0. Then split each factor to be 0. We solve, we get x equals negative half 3/4. So that's a 2x intercept. So this function has two zeros. One zero is x value is negative half. Another value is x equals 3/4. Well, we can understand that those just two x intercepts. Negative half, 0, 3/4, 0. Anyone has any question? All right, keep moving. The above is positive ax squared, negative 2x, negative 3. Right? Let's see this one. Negative ax squared minus 10x plus 3. So the leading term is negative. We don't like it. So what do? We factor out the negative sign. Then inside the parentheses, the leading term becomes positive. And the other two terms gets changed out accordingly. Right? Negative 10x now inside the parentheses become 10x. Positive 3 before, now inside the parentheses becomes negative 3 because we have this negative sign in front. And then this is the same as above, right? Oh, we didn't factor this. We didn't factor this. Okay, so same process. We think, okay, how do I play with, so a times 3, that's 24. So how do I get a 10 to play those factors? So better to be 2x times negative 1 would be negative 2. And 3 times 4x would be 12x. Then minus 2x, that's 10x, right? 12x minus 10x. So multiply negative 1 on both sides, get this, right? By zero property, each factor can be 0. So solve x equals negative 3/2 and quarter. Anyone has any question? If you don't know factor, right? You don't want to factor, that's fine. Use quadratic formula. All right. Quadratic formula will have these ABCs. Where does this ABC come from? A is a number before x squared. B is a number before x. C is a constant term in the equation. So let's see this one. Negative ax squared minus 10x plus 3. So the number before x squared is 8. So a is a negative 8. The number before negative 10x is b. So b equals to negative 10. And the constant term is the number itself. So c equals to 3. Then the rest is just plug in. Plug in, do the calculations. In the end, we'll also get two solutions, negative 3/2 and quarter. All right. So quadratic works all the time. Any questions? Let's see how we use in life. So this example is in John is a garden designer. His client has requested him to build a rectangle garden with an area of 14 square feet. The client also requested the length of the garden be 3 less than twice the width. So what is the length? The length is 3 less than what? Twice the width. Twice the width, so it's 2w minus 3. Find the length and width of the garden. Well, we're given the area is 14. We just do, so the area equals 14. So just length times width equals 14, right? And also we have this length equal to 2w minus 3 from this. So we have this system of equations. There's two equations, which makes a system of equations. So what do? Well, L can be represented as 2w minus 3. So we can use substitution. Substitute L with w into the first equation, right? The first equation you see L times w equals 14. So 2w minus 3 times w equals 14. So that means 2w squared minus 3w minus 14 equals 0. Well, we can factor this. 2w squared, we factor as 2w, negative 14, we factor as a negative 7, and positive 2. In that case, we get negative 7w plus 4w, that's negative 3w. Using zero property, we get two solutions. W equals 7/2 or negative 2. Well, because this is a life application, right? And negative 2, we don't want to measure length of one-dimensional stuff with negative numbers. So we just reject this as negative 2. So we just say, okay, the width equals 7/2. And length doubles it minus 3. So in the end, we'll get 4. Anyone has any question? All right. Let's see this example. Determine the positive number whose square exceeds twice its value by 15. So we need to translate this into mathematics. Right. Let's call this number n. Its square, which is n squared, yeah, exceeds twice its value. Exceeds more than, so subtract 2n. Twice its value, 2n. By 15. 15. So n squared minus 4n equals 15. Quadratic equation, move 15 to the other side, become negative 15. Then now we can factor this as n minus 5, n plus 3. Solve by zero property. So n equals 5 and negative 3. But here we only want the positive number. So we ignore negative 3. So we see in the end, n equals to 3. Okay, the key of this application is to form the right equation and solve it. Any question? Okay, keep going. Gina is going to throw a ball from the top floor of her middle school. The function downward parabola, right? Quadratic downward parabola models the height h of t of the ball above the ground as a function time t. Question 8. The height of the ball will be at t equals 1 second. So let's just find h of 1, right? So plug in 1 for t, gets 64. B, the times the ball will be 40 feet above the ground. So that means feet, the height equals 48. We need to solve for the t, for time. What time the ball hits 48? So function value is 48. Then the function is this. We simplify it. Subtract 48 on both sides. Then we factor out negative 16t. Then the rest of it is t minus 2, because we are factoring out the negative sign. By using zero property, so negative 16t equals 0, and t minus 2 is 0. So solve those two linear equations, t equals 0, comma 2. C is asking when the ball hits the ground. Well, when the ball hits the ground, there's no more height. The height equals 0. So solving for zeros of the property of the function. So that means this function has to be 0. And we factor out negative 16. We see negative 16 is a common factor of those three terms. So we get a much simpler expression, t squared minus 2t minus 3. And that can be factored, right? T minus 3 and t plus 2. Then we solve, we get t equals to 3 and negative 2. But we don't measure time negatively. So we just choose t equals 3. And h of 3 indeed is 0. Anyone has any question? Let's see this example. Similar. This example is in Caroline is going to toss a ball from the top floor of a middle school. The function, downward parabola, model the height. This is the last one. Maybe you guys want to try it. You know what? It's similar to the previous one. Okay, let me finish. So the A is seen 500 times or 1 time or 2 times because it's a parabola, right? Downward parabola. When the ball's height is 192 feet. That means the height equals 192. So we set the function to be 192. Well, subtract 192 on both sides. So they are gone. So it becomes negative 16t squared plus 16t equals 0. We factor out the negative 16t. Right? Then we have t minus 1 inside parentheses. We solve the two factors. So t equals 0 and 1. So which means, so before she tossed the ball, that's 192. Then after 1 second, after one second or hour, we didn't really see it. Then it's a 192 again. So which means h of 0 equals 192, h of 1 equals 192. Because downward parabola, right? As long as it's not the vertex, the vertex only has one value. This is B. Find the time when the ball hits the ground. That means the height is 0, right? We just set the function to be 0. And we can factor out negative 16, because the leading term is negative. So we like to factor out the negative number. Then inside parentheses, we have t squared minus t minus 12 equals 0. So divided by negative 16 on both sides, left with t squared minus t minus 12 equals 0. Then we can factor this, right? Minus 4, positive 3. Minus 4, positive 3. Add negative 4 and 3, we get negative 1. Multiply, we get negative 12. So we solve the t equals 4 and negative 3. Well, we don't measure time negatively, so t equals 4. So that means h of 4 equals 0. So after 4 units of time, the ball hits the ground. Anyone has any questions? That's all I have to say for today. I don't know why it still shows one more page here. I'm trying to get rid of it. Cannot get rid of it. Okay, all the concepts are not difficult, right? So you have no questions, go ahead to start, use the rest of the time to do your homework. And if you do have some other questions, I'm here to answer your questions. Thank you. You too. Thank you. Thank you.
Professor,
Yes.
if I came a little late, did you still get me on attendance?
Yes.
Okay, thank you so much. Bye.
You're welcome. Bye-bye. Thank you. You too. Have a good weekend.
Professor,
Yeah.
I wanted to ask you a question about our first exam.
Yes.
I know you said to email you. I forgot to email you. My grade, like, it just didn't really make sense to me. I thought I did a lot better on it.
Okay. I can go over with you.
Yeah, if you don't mind, please.
I don't mind at all. Yeah, just let's see. Just wait for. If you don't want to share with other students, let's just wait for a little bit.
Okay. All right, thank you. I'll wait.
You're welcome. Let me open it. I'm gonna open math. I'm sorry. Who was asking? It's a
Medina.
math. Oh, okay.
Yeah.
You find you on the grade book.
Okay.
Yeah, find you. Let me see. Term expand. So we're looking for exam 1. Oh, I see. Okay, let me open up. Right. Okay. Okay, the rest of you, if you don't have questions, you may leave and starting to do your homework. If you do have questions, you can speak to me. Okay, Martina, let's do this.
Yeah.
You don't want me to share the screen with you, right? Do you want me to show your exam?
I mean, honestly, I don't really mind.
Oh, okay. In
Yeah, I
that
don't
case, I
mind.
can.
Yeah, like I'm not like that great at math, so I didn't think I was gonna get like 100, but I thought I was at least gonna get like a 75.
Okay, if you don't care, other
Yeah, I
people
don't
can.
mind. I don't mind.
Okay.
Okay, I see. Oh, okay.
Yeah, this is z. So if z is negative,
Okay.
z is negative, how can z be equal to negative z? This has to be less than negative z, right? Because negative will be positive. This will be positive. So the first one is wrong.
Oh, okay, okay.
Yeah. C minus 1 is 10. Those two are wrong.
Okay.
So C minus 1 is C plus negative y.
Oh, so was that positive 10? I mean, was that one positive 10?
Exactly. That should be positive.
Oh, okay.
So now you switch y minus C. This should be negative 10.
Okay, I see, I see. Okay.
This is C minus 1.
Okay.
Okay. And this one is right. You get full credits.
Yeah, yeah.
This one is right. You get full credits.
Okay. Oh,
Yeah,
that
those
was
two.
wrong?
Right. Let's see the domain. You see the domains from negative 3 to 2.
Yeah.
You read the x-axis, right? From negative 3 to 2. And range from negative 2 to 1. You read the y-axis. Do you see my cursor?
Yeah.
You see, the lowest point of y is negative 2. The highest point is 1. So this should be negative 2 up to 1. The domain is x value. From
Yeah.
left to right, negative 3 up to 2. So those two are wrong.
Okay.
System equation you did well. You get full credits.
Okay.
This you get full credits. This you get full credits. Those two are wrong. Let's see. Some of men in J's history class at Chicago University is A less than 2 times the
Okay.
number of women. A less than 2 times of the number of women. You did it right. Write an expression that represents the number of men. Oh, you need to use W.
Oh. Oh, so I can't get any credit for that one because I put M?
You should get credits. You should get some credits for this. But for next time, you see the system agrees you're wrong.
Yeah, yeah.
I have to go with the system, you know?
You see, I didn't, I think it's because I read men and okay.
Yeah. But anyway, I give you I give you full credits for that because you only, right, that's, this one you did right, you get full credits. This one you get full credits. This one, let's see what's wrong. The equation of the line perpendicular to the given line through the point 2, negative 3 will be this. Let's see, what's the slope of this one? From this point,
I think I was confused with this one because I couldn't remember if perpendicular meant that the slope was opposite or not.
opposite the inverse. Opposite the inverse. So if you use 4 over 5, that means the slope of this one is negative 5 over 4. No, this is a positive slope. The line given is positive slope. Here, you should have a negative slope. It's negative opposite.
Okay.
It's opposite inverse. So this one you did it wrong. You get a
Can I
1
see
credit.
the answer? Can I see the answer for that, like the correct answer with the answer key for that one?
Oh, sure.
Sorry, I'm just like right, like where the key is up there, yeah.
How to work. It's negative 4 over 5.
Oh.
You just, right.
Okay, I
It's just
see.
missing the 5. That's why you did. That's why you didn't get it. Well, let me give you 2 credits.
Okay, that makes sense. Okay.
This one you get full credits. This one you get full credits. This one, if Ian sells 70 miles, how much profit does he make? Well, 70 miles times 150, right?
Yeah.
Then minus each meal costs 50. So 150 minus 50, that's 100. 100 times 70.
Oh, it's 7,600.
7,000. Then you have the minus 26 expenses.
Yeah, okay, I see.
Let's see this equation. Rather than inequality, use x represents the problem of finding how many meals he must sell to make a profit at least 2,000. Okay, this is right. Let's see. 150x. Okay, you forgot to subtract this 50.
The 50, yeah.
The 50 cost. 50 cost.
Oh no, wait, professor. Wait, professor. I think I did because I did 150x minus $29.50. So I think I just put it together because the monthly expenses are $2,900.
Oh, no. This is for each meal. This 50 is for
Oh,
each meal. 29 is one shot.
okay.
Oh, I see. You should
Yeah.
do 150 minus 50, which is 100x minus 2,900.
Oh, that makes sense. Okay. Okay.
Right.
I see
You
that.
still
Okay.
get, you still get a partial credits for this anyway.
Yeah, yeah. Okay.
So this one you get a full credits. This
Yeah,
one you
that one I
didn't do.
didn't do. I
Well,
was trying really hard. I couldn't understand like
okay.
what I was supposed to replace.
What does the function do? The function says whatever the input is, multiply by -5 with the input plus 15 to it. So what is the input for x, f of x minus 4? The input is just x minus 4, right? You just
Okay, yeah.
multiply -5. Multiply -5 with the input, then plus 15. That's the function.
I think I
Then
was getting confused because I was trying to add to like I remember in one of the homeworks it was how we had to like replace every occurrence of x with that, and I think I was getting confused with that.
no, this you just read. Okay, the function does multiply -5 with the input plus 15. So first one you multiply -5 with the input plus 15. F of 4x multiply -5 plus 15. Then you simplify from there.
Okay, yeah, I see now.
Okay.
Right. That's
So
okay.
this one you do it right, you get full credits. This one you're missing those two parts, so you only get partial credits.
Okay, yeah.
Yeah. This one you did it right, you get full credits. You did it right, you get full credits. That's it. So let me save the
Okay.
change. Now you should have better grades. Let's see your new grades. 72.6.
Okay. All right. Thank you, Professor.
So let me ask you, did you do the practice exam?
I think I looked over the questions. I don't know if I completed all of them, to be honest.
You have to complete them. You have to
The
complete
thing
them
is,
a couple of
what I've
times.
been, yeah,
Yeah.
I think I messed up because what I've been doing is like when I've been doing like the homework, I've been trying to like take like notes because like sometimes when you look over the book, it like will give you like, that's why I was able to remember that like perpendicular is like opposite. But I think I need to focus more on the practice exams and try more on the homework.
You really need to practice, right? Because
Yeah.
72.6 is not a good grade.
Yeah,
All
I
right.
know. I felt this class last semester too. All right.
Okay.
Thank you so much, Professor.
You're welcome.
Good night.
Good night. Anybody else has any questions? Let me stop. Actually, let me stop recording.